All right. Hi, everyone. Thank you for joining today. It's our fourth session in the series. We are obviously here for the UN Datathon Pets track. These are the Oblivious office hours. And today we want to do a deep dive into the Pandas library that we have developed for private Python. And I have Hardik Kapoor with me, who is also part of the Oblivious team, and he will be taking us through a deep dive into all the coding sections. So I'm pretty excited for this one. Quick refresher. So I'm Ali Rizvi. I'm a product lead at Oblivious for the anti-granular product, which is a private Python offering to help data scientists carry out responsible machine learning and responsible data science. I have a background in machine learning from the University of Oxford, and I have been part of various startups focusing on robotics, cloud computing in the health space. And so to remind you, these are the series of office hours we are doing. We are on the fourth one today. On Monday, we will code a classification model together. And then all of next week, we have various machine learning focused office hours as well. I would love if everybody can go to the Slido as well, because there you can post your questions. This is how the Slido interface will look for you. There you can put in your questions and other people can see what questions are being asked and they can upvote on the question. So that way we can know which question is sort of the most important for the group right now. And then when we are done with the coding and the presentation, we will come back and start answering those questions. If you want to follow along, I'll give you a couple of minutes. If you did not set this up yesterday, please go to antigranular.com, and there you will be able to quickly set up your account using Google Sign In. There's not a very lengthy process. You can just click in, and then it will give you the option to sign in with your Google ID, and then you will be able to quickly follow along the things that Hardik will take everyone through. At any point, if you want us to quickly pause or give you any quick clarification on all the things that we are doing, just raise your hand in the Zoom and we can quickly pause and clarify, because while setting up the collab or the Google environment, maybe you run into some issues and you want us to quickly help you bring along. So please feel free to raise your hand at any point. And so again, reminder of the objective, the purpose and the agenda, of course, as always, is we want you to have a great hackathon experience. We want to prepare you for the 72 hours hackathon that will happen between November 3rd and 7th. Am I correct? 3, 4, 5. No, 5th of November, sorry. And then we also want to give you the tools and techniques to increase your experience as data scientists so that in the future you can carry out finding insights from data without compromising the privacy of individuals or institutions. I'll briefly take people through a quick refresher of what private Python or anti-granular tries to achieve. And the most important brief thing to remember is that we don't necessarily need to look at the actual data itself to start taking insights from it. And the important kind of visual to remember is that, for example, we took this image of a car, which has noise added to it. We can't be sure how many cars are in this image, but we already can start sensing that there may be cars in this image. As we reduce the noise, we can start even counting the cars. We can start seeing where the cars are. But even with this, where you know how many cars there are, you can tell their colors, you can tell their configuration, you can even start telling their models. You can't see the number plate, so you don't have access to the individual level data or something that may help you make individual level inferences, but you can still find out a lot about the data set, even when there is a significant level of noise added in. And that's the trade-off we are always doing with responsible data science and private Python, is this trade-off between noise and accuracy, insights and privacy preservation. And so this would be the kind of data that has no noise added in it, and you can see number plates and everything, and you can maybe start making very individual level insights. But ideally, you should not have to do this, and you can still do responsible data science by using this kind of data sets. And so that's the main kind of analogy I want you to keep in mind as you go along. And yeah, without further ado, I think Hardik, over to you, and you can take us through the private Python and Pandas.
Sure. Thank you so much, Ali. So, hi everybody. I'm Hardik Kapoor. I'm a software engineer at Oblivious. I'm working on building anti-granular, and I'm basically an algorithms engineer. So I work on the algorithm sides of anti-granular. So I'll just share my screen. Is it visible?
Yes.
Cool. Perfect. So today I'll be walking you through OP Pandas. Now, what is OP Pandas? OP Pandas is a differentially private version of the Pandas library. OP just means Oblivious Private Python. So this is Oblivious Private Python Pandas. So this will let us, this has, instead of data frames and series, as you are used to in Pandas, we have private data frames and private series. So basically what private data frames and private series are that they are private versions of the respective things. So by private version, I mean that you can't look at the record level information. You can't access the granularity within the data, but you can do statistics operations on it, and all the releases will be differentially private. As Ali greatly explained, differentially private is just adding noise so that you can't find out who is actually in the data or not. So I've created a notebook. It contains a lot of information. So if you feel like that you're not able to follow through, or if you have any doubts, just please let me know and we can explain further on that. So, okay. So the first step is to install, import, and connect to anti-granular. So anti-granular is a package which is available on PyPy. So you can just do pip install anti-granular wherever you want in Jupyter Notebook, in your VS Code, or in Collab, as I'm using Collab. So when you do pip install anti-granular, anti-granular package is installed within the server. After that, you can go to the anti-granular site. This is the sandbox competition which I'm using for this walkthrough. And here you can just copy paste these two lines to log in within the AG environment. So ag.login, and these two are the client secrets so that you can log in. So this is what I've done here. I'll of course hide my name and secret so you don't use it. So within this, if you read the logs, you can see that the data set medical treatment is loaded into the kernel as medical treatment. So we won't be using much of this, but it's just that let's move forward. So within OP Pandas, as I told you, there are two types of data. Uh, like instead of data frame and series, you have private data frame and private series. So you can import them just like OP Pandas import private data frame and private series. So how do you get the data actually? So there are three ways to get the data within the private data frame. So one is by connecting to a competition or a data set. We have multiple data sets within Altimeter too. So if you connect to a competition, you'll just be getting this dictionary, medical treatment. Now the medical treatment dictionary looks like this. In this competition, it's medical treatment. In other competitions, it will be different. So the train X, there's train Y, and there's text X. Now test Y, we have it in our backend servers. We don't provide it to the users so that we can use it for testing, like how good the solution is and all of that. So the train X and train Y, they are private data frames, and test X is a normal data frame. So as it's a dictionary, you can just access the train X and train Y, and you'll get these two as private data frames, and this is a normal data frame. Now, another way to create a private series is just by wrapping a Pandas series. So let's say I have created a Pandas series within the AG environment with the name of test underscore series, and it contains these elements. Now you can just add it, create, wrap this into a private series by using this functionality, this private series and then series 0s. Now what this does is after this, whenever you try to access any member of the private series, you won't be able to access the granularity of the data. You won't be able to access the record level information. You'll just be able to access the aggregates, and those are also differentially private. And of course, in like I'll just explain a little bit about differential privacy so that you have a little bit more background on why we are using metadata. So basically, in differential privacy, the amount of noise added is mostly dependent on three things: the size of the data set, the function, obviously, which we are using, and the bounds. So those bounds we have to provide to our private series or private data frame um, API so that we know what amount of noise should be added so that the releases are differentially private. So here I'm just putting it as a random number that it's 0 to 10. So this is how you create a private series. The priv underscore s, it will be a private series. Now,
Just
similarly,
a
you can
just a
use,
quick point, Hardik. Maybe just checking with the audience participants that I can see obviously some of you are trying to make the accounts now. Does anybody want us to quickly pause and like any debugging you need? Are you running into any issues? Do you need our help? Please just put it in chat and I'll be able to assist you offline to make sure that you can follow along, Hardik. Yeah, sorry, Hardik, you can continue.
sure, no worries. So the next is creating a private data frame. It's very similar to creating a private series. You can just create the data. This is the dictionary of data. As you know that dictionaries can be used to create a data frame within Pandas. And this is the metadata. Now metadata here is also a dictionary because different columns will have different bounds and so on. Now, one interesting thing here is that the sex, that's of string format. Now, within a private data frame and private series, you don't require to give the bounds of strings because obviously string doesn't have bounds. But also you can't do aggregate because you can't do aggregate aggregation and statistical analysis over strings. So that's why for the column name sex, you don't give any metadata. So that's how the private data frame is created. Just creating a data frame and wrapping it with a private data frame. Now, within the AG environment, you can also import external data. Let's say you have some local data and you want to test like how things work within AG, and for that you can just import that data from your local machine within the AG environment. So here I've just created two private data frames which we'll be using for our analysis in this notebook. So these two data frames, the first one, it contains the name of the person, the age of the person, and the salary of the person. Right now, it's just random variables, but you can assume that this is your bank accounts, like this is a bank's data, which should not be leaked and which is very private. So for that, you can just to import it within the AG environment, you can just use session.private import. The session object is created here when you first log in. So you can use that to import data within the AG environment. Now, this is the second data frame I've created. It's just a random two columns with some NANs. So to see how cleaning of data also works within AG. So I've given 0.5 probability to for every column, and there can be any ends within the column. So let's say the name of this data frame is df2. Now I'm just creating in this cell, I'm just creating a private data frame out of the imported data frame. Now this is exactly similar to what we have done before, just creating a data frame out of a private data frame out of a data frame. So we'll just be doing that. Now let's get into the functions of private data frames. Uh, if you guys, of course, have any problem, you can just raise a hand or comment, and we can. Sorry, someone just message.
Yeah, I'll tackle that in the chat. No worries.
Sure. Okay. So okay, let's see how you can view the data. Now, of course, you cannot view the data directly. That's the whole concept of private data frame and private series. But you can analyze and obtain statistical information about the data that offer differential privacy guarantees. Now, the first thing is to view the details of the data. You want to know what types of columns there are. What what's the metadata like? What's the bounds of all the columns, and what are the D types? So to access that, you just have to write simple functions like dot columns, dot metadata, and dot t types. Now, this is an interesting function, agprint. What agprint does is it prints a non-private data which is within your AG environment to your local environment. So the columns, that's a non-private data. That's public information, you can assume. So that you can print. But if you try to AG print a private data frame, that's not possible. That would throw an error.
Quick
So
question,
you can
Hardik.
use,
Can
sure,
you share the link to this collab in the chat? Because some
for
people are
sure,
trying
for
to.
sure,
Yeah.
for sure. I'll just make this share. Can you check if you can open this? Okay, so let's move ahead. So within the private data frame, I have three columns, right? Name, age, and salary. So that's being printed here. Of course, the metadata, the bounds of the data that I have set is also present within the private data frame. So that's also being printed here. And here, as you can see, the D types are also being printed. So the name is of the type object. Object is basically a string. So within private data frames, we allow five types of data: float, integers, boolean, strings, and datetime object. So if it's object, it can either be string or datetime, and you don't need metadata for either one of those because you can't do statistical analysis over them. So this is how these three APIs work: the columns, metadata, and datetymps. Now, to get a quick statistic of what the data looks like, you can also use describe. So the describe functionality is exactly similar to Pandas. Just you have to supply the private data frame describe with epsilon. So the concept of epsilon is, in very simple terms, that the more the epsilon, you are losing more privacy guarantees, and the less the epsilon, you are losing less privacy guarantees. So basically, more epsilon means less noise. You'll be able to look at the data more clearly, but you'll be losing more information. Less epsilon means more noise. You won't be able to get the exact pinpoint of what the data looks like, but obviously privacy won't be leaked for because of that. So we get the counts, the mean, the standard deviation, and all of that. So this describe is how the we have tried to make the APIs of private data frame and private series in such a way that users can easily move from pandas to OP pandas. So within every statistical release, you just have to put in an extra argument that is epsilon to for us to let for you to tell us that what should be the privacy guarantees of this function. So here I've just used epsilon is equal to 1, which is obviously a lot. You can have less epsilon too. So so as I told you about AG print, it just prints the variable which is present within the AG environment, which is present within the enclave. Um, also have another function similar to that, which is export. So what export does is it takes out the variable from it takes out a non-private variable from the enclave and puts it within our local Jupyter environment. So you can use those non-private variables within your local environment too. Like here, I have the private describe. I've just exported that from the AG environment, and I'm trying to print it within my local Jupyter environment. So as you can see, that works. So even here, if you try to print or if you try to export anything which is private, you won't be able to. It will throw a nasty error. So okay, let's move ahead to next set of APIs, um, which is cleaning the data. So for cleaning the data, we have a very important function which is drop in. So if, as you all know, every data set is not perfect. It contains a lot of NANs and different values. So for that, you can use drop NA to just remove all the NANs and then do describe and all of the functionalities over it. So this is just I'm using the second data frame which contained NANs with a probability of zero point 0.5. So if both the columns contain NaN with a probability of zero point 0.5, uh, if both the columns contain NaNs with probability of zero point 0.5, the probability of a record not having NaN is 0.25. So as the size of the data set is around 10,000, approximately after we drop NaNs, the count should be around 2,500. So that's what I'm trying. That's my hypothesis. Let's test if that's correct or not. So here I do drop NA with access equal to 0. Access equal to 0 means it will remove the rows. And then I do describe with epsilon is equal to 1. So as you can see, the result, the count is really close to what we expected. It should be around 2,500 and it's 2,520. So this is how the drop any and with that describe works. So this is the DF2. That's the original data frame within my local environment, and this is the differential private release. So I'm just trying to show you that differential. This is the differential private release will be with the noise added, so it will be a little bit different, but it's really close to the actual value. Cool. So next, we move ahead and see how do we select data. That's a very major part of working with data frames and series and in turn private data frames and private series. So there are two major functionalities which I have shown you here. That's the apply map and the map. The apply map is present within private data frame, and map is present within the private series. So okay, so first, let's go with the easy task. How do I select a single column? It's exactly the same as to in a private data frame, as to in a data frame. You can just use the column's name in square brackets, and you'll get the private series out of it. If you use private data frame and then the column's name, you'll get a private series out of it. So as you can see, if I describe, this is the age column of the private data frame. So if you describe, you get the counts and all of that, and the metadata, of course, will be 0 to 80, because even here the metadata is 0, 80. The age is metadata. So you're just getting that column as a private series. Now next, you can also select multiple columns from within the private data frame. That can be done by just giving a list of columns. If you do this, the output will be a private data frame. It will be exactly the same as the previous data frame, just with the names column removed. So we can see that the columns now contain only age and salary, and the metadata now has the metadata, the bounds of the age and salary column. Now the interesting part. You can also use apply map and such different functions on private data frames. So this is an example on how you can use apply map on a private data frame. Now let's say I want to get the length of all of the strings within the private data frame. And if it's not a string, I just want to divide it by two. So this is what the function is doing here. Uh, Also, one point to notice within anti-granular, we are very strict with the types. So the types should be conformant and should be what the input and output expect to be. So that's why we just use type annotations in each of the functions using with apply map and all of these. So you just to get the output just as similar to the pandas, you just do private data frame dot apply map and the function. Now here also I've sent epsilon, but you might be asking why did I send epsilon here? The output is also a private data frame by apply map. So the epsilon here is used to calculate the new bounds. If you write any like non-linear function or a quadratic function or anything like that, you can the bounds will change, of course. Like if the function is mapping from an integer to an integer, the bounds will change. So for that, even if the input type is a string and the output type is an integer, you don't have the bounds for the string, but you have the bounds for the integer. You want to calculate the bounds for the integer. So that's being done. The estimation of the bounds is being done using this epsilon. So epsilon is equal to 1 is solely used to calculate, to estimate what the output bounds would be. So here, the result is a private data frame, but the bounds calculated is using this epsilon. So if I print the metadata and describe what the data looks like, as so here, as you can see that the bounds of the name now there's also a name column present, a name key present within the metadata because the type changed from integer or changed from string to an integer. So now the bounds are 8 to 16. It's a rough estimation. Um, and I'll just, in the original function, I've taken the length of the strings as 10. So now the bounds are being given as 8 to 16. A rough estimation of the bounds is being calculated in the power of 2. So that's why it's in 8 to 16. And age, of course, 80 divided by 2 is 40, and the nearest 2 to the power is 64. So it's being estimated in such a way. So age is 0 to 64, and salary, of course, everything changes. The bounds changes because it's being divided by 2. So this is the how the describe looks like, how the data looks like within the count by the count, mean, standard deviation, and all. Now, this is just me calculating the original results, how the data would look like if the data if it was not private. So as you can see, the describe is pretty close. It won't exactly be the same because the releases are differentially private, but it's pretty close. So you can get meaningful analysis out of the releases that the OP Pandas gives you. Now next we have map, which is applied on private series. So let's say I just want to divide the age by half. I like someone is 80 years. So for that you use map. So I just define a function, and as you can see, type annotations are pretty important here. So I give the type annotation that x will be of type integer, but the output can be of type float. So now this would be pretty important. This would be a pretty important line for you all in the upcoming hackathon, because this will be used to 1 or 10 code or like categorize data from strings to integer. So here I'm doing into float, so it doesn't really matter much. But the as you can see, the age, like after applying this function x divided by 2, the age, the metadata for age changes from 0 to 80 to 0 to 64. Here also I've sent in epsilon, but you can also do it without the epsilon by just providing the bounds. What you think of? That's another API using output underscore bounds. You can look at it in the docs. I'll just share the docs link with you after this presentation. And by providing output underscore bounds, you're just telling me that, okay, you don't have to spend epsilon. These are the output bounds. You can work with that. And we'll clip the data within those bounds so that no excess outliers are there. And then we'll do differential private releases on that. So there are two APIs for map and apply map. Okay. So the next is operations. So there are three types of operations that we provide: unary operations, binary operations, and bitwise operations. These three are pretty popular within the data science industry. So unary operations are just which apply element-wise on the data, and just one private data frame or one private series is required for that. Unary means one. So for that, if you want to, let's say, negate the whole data, so you can just use minus operator. You can just use minus operator. Or if you just want to get the bitwise negation, you can just use the tilde operation, and so on. So here I use the export function to get the age and the salary, the describe of age and the salary, and of course also the negation of it. So here's how the data would look like. If you negate, the mean and the standard deviation would approximately be the opposite, like just the negative. But these two exactly are not matching because these are private, differentially private releases. So the noise added is variable each time. So that's why the mean and the standard deviation and the positive negatives, these are all negative. So the next type of thing we provide, operations we provide, is binary operations. These are also similar to the data frame and series. You can use it with you can use the binary operations with multiple private data frames in private series, and also with scalars. And it works just in the similar way as Pandas. It um, vectorizes it and then adds it and all of that. But the important thing here is we are calculating the bounds for you. So you don't have to provide epsilon or anything like that. Because here we have only allowed 3 or 4 uh, set types of binary operations like addition, multiplication, and it's easy to calculate the bounds or the output bounds using the input bounds. So let's say I just wanna I there's a private data. The PDF is the private data frame of
Hardik,
age and the salary
quick
column.
question. There we have one question in the chat around a person who
Sure.
is encountering an error on the private data series. They're importing it and they're getting a name error. Any idea why this could be?
I'll have to check that. Are you using private underscore import to import the data?
Santosa, please feel free to unmute, and if you want to ask Hardik directly.
Yeah, sure. Yeah. What was your statement again?
Are you
Yeah,
using private import for importing the data within AG environment?
No.
Okay, so what's the name error for? Can I just get a
It's
can you
a
just send me the code snippet?
yeah. Just one sec.
Sure.
It's a name error. It's basically stating that the private series is not defined, even though I've used the from OP underscore pandas import private series.
Huh,
I'm
that's
just trying
weird.
to. Yeah,
Can you
that's
send
why.
me the yeah? Can you send me the code snippet because that shouldn't happen. Just
No,
2 or 3 things you can check is that private C's, P and S are capital, and then you are writing everything within the percentile AG cell magic, which creates when you log in.
one sec.
Hello?
Also,
Yeah,
if we want to do a quick debug session, like I think Santosa, you can also share your screen, and
yeah, sure.
they can do a quick debug.
Sure, yeah.
One sec.
Yeah, and for
On
while that happens, yeah, please go ahead.
all good, all good.
So it works now on your end?
No, not yet.
Okay.
Okay.
Yeah, just for people who are joining in, just repeat. So you can quickly go to antigranule.com. You can just sign in with your Google ID. I have shared the link to this collab notebook that Hardik is sharing on the screen in the chat. You can go, you can copy this notebook, and then in the cell number 2, you need to add your own personal session details, and you can get them from the Antigranular website in the sandbox competition. So if you go to the sandbox, this what Hardik is showing, you just copy that, and then you paste that into cell number 2, and that would be your secure session details in your collab notebook. It basically just tells your collab notebook where to get all this data and information from. And yeah, you can then follow along.
Will it be possible for me to share my screen then? It's
Yeah,
just
Hardik, I think you need to stop sharing for that though.
Sure, I'll just.
my apology.
You should be able to share now.
Yep.
Do you have the permissions, or do you want me to do anything?
I am trying to do something. One sec.
Sure, no worries.
There you go. So are you guys looking at my screen?
Yep.
Yes.
So this is line 8, which is that
Mhm.
I'm ordering the OP pandas,
Yeah.
and I'm still in the name error.
Is
Oh, you haven't written percentile AG for this cell.
Sorry.
Above this cell. In cell number 11, this cell you
Also,
yeah, you
I
have to
have
write percent
right. Oh,
because
can I know what does this mean then?
sure. So percentile AG is just basically a cell magic. So what it's doing is taking this snippet of code, moving it to our enclaves, our server, our like secure computation environment, and computing it there and just throwing back the results. So that's why you have to write percentile AG because private data frame and private series are installed in a remote server, remote enclave. So percentile
I
AG just moves the code from here to there in simple
gotcha.
terms.
Thank you so much for that. I'll stop my
No
screen.
worries.
Screen sharing there.
Sure.
Yeah, and actually, this is, I think, a great teachable moment because what is happening is that technically your code has access to 2 environments right now where it can run. So some cells where you don't say percentile AG, they run in the normal flow, like they just run on your kind of the Google's cloud machine, the normal kind of collab repo environment. And when you say percentile AG, that code actually runs in the secure enclave. that happens in the back end, and that's what the secure credentials are for. The secure credentials are kind of your remote link to the secure Nitro enclave. And so when you say percentile AG, Python already just runs that particular cell in the secure environment. And I think that's the beauty of like using private Python, that all this complexity is hidden away from you. For you, it's like literally 4 characters, and then the magic happens. Yeah, I'll stop there, Hardik. You can add more if you want.
Yep. No, I think that's more than enough to explain the personality. So we can just move ahead with the Panda stuff. Can you, is my screen visible?
Yes.
Cool. Okay. So again, if you have any doubts or any questions you want to ask me, you can just stop me and then we can do debugging and all of that. So, okay, moving on. So we have binary operations too. So binary operations are exactly similar to how they perform in the data frame and series. You can add two private data frames, you can multiply two private data frames, you can add it with a scalar and it factorizes it and then adds them together, and multiple things. So the beauty of this is that you don't have to provide any epsilon with it or any bounds like what you think the output bound would be. Because you are adding two private data frames, both of them would contain a bound. And we are just in the backend, we are just calculating the output bounds for you. Like let's say you take out the age and the salary column out of the private data frame, and you do a complex operation, let's say PDF plus PDF 10 times the PDF. So the here in the last record, we saw that age has changed to 0 to 64. The metadata for age has changed to 0 to 64. So after doing this operation, the expected min max for age and salary would be 0 to 704 and 11, 12 x, whatever that is. Now let's say you want to do another operation. You want to divide all of this by 1,000. Now the expected min-max would change by the operation. Now, as you can see, the calculating bounds using just this function is pretty simple. So we don't ask you to provide any epsilon or provide anything. We just calculate the bounds. So after calculating the bounds, you can see that they are exactly the same as what we expected. So that's how the binary operations and everything work. Even in unary operations, the bounds are recalculated for you. Same for bitwise operations. Now, for bitwise operations, I've just created two private series with binary numbers, and it's of 10,000 size. So if you describe these two series, you can see that the mean and the median, the mean is 0.2 for one and then 0 for the other. But if you do AND of those two series, the mean should decrease a little bit because ones and zeros would cancel out and the output would provide 0. So as you can see, that's happening. That's just the case. This mean being 0 is not exactly correct because it's a noisy result. So there might be some ones present, but the mean is still 0. So that's why it's exactly 0, but it's because of the noise. It's not exactly 0. So moving ahead, we also have joins and where the where condition within private data frame and private series. So join is also same as the pandas join, and the where is also the same as pandas where. Just here, what we are doing is, of course, you have outer join, inner join, and all of those. And we're just keeping the track of bounds and the column names and all of that. So if you have two private data frame, let's say the first private data frame is a randomly sampled private data frame with 3 columns. It's not 4 columns, 3 columns, and the metadata is 0 to 100 for all the columns. The size is 1,000. Now, the second private data frame contains 2 columns E and F, and the metadata is -100 to 100 for all the columns. Now, let's say you want to join these two using outer join. How do you do that? It's pretty simple. Just use PDF dot join PDF2. And how do you want to join it? It's outer. So this function is exactly the same as our data frame and how you join two data frames. So you'll just get 5 columns now instead of 3 or 2, and there will be A B C D E F, A B C E F, and that's how the and as you can see the count and all of that. As you can see in the describe, the count, the mean, and the standard deviation, those are all calculated for that. So as ENF columns contain negative 100, 200 numbers, the mean is approximately 0 because it's randomly sampled. And ABC, as they contain 0 to 100, the mean is approximately 50 for all of them. So that's how joins work within OP Pandas. Now, you can also join a private data frame with a private series. Let's say you have a series with the name series with a metadata of 0 to 100 and the size of 1000. So one thing to note here is that the type you send the metadata in private data frame and private series in a different way. So as there are multiple columns in private data frame, you send a dictionary with column and the bounds for it. But in a private series, you can just send a tuple because we know that it'll just be a singular column. So the metadata for this series is 0 to 100. The bounds for this series is 0 to 100. Now you can also join these. Will be using inner join here because we support both. So the inner join of the PDF and series will look like this. The describe tells us a lot about the data. So the mean and the standard deviation, the mean will be around 50 because it's randomly sampled from 0 to 100 and all of that. So another functionality we have within OP Pandas is the where query. So the where query is the same. Wherever you just provide a condition, and if the condition is true, it keeps that value or puts one on it, whatever you want. And if it's not, then you put NaNs over it. So here I'm just doing period of dot where PDF is greater than 0. So wherever the values are greater than 0, and except that, all of the values will be none. NaN, sorry. So this is how the describe looks like for that. I'll just move a little bit faster because only 12 minutes are remaining. So there are multiple statistical methods too. Now all of the releases, all of the things you can print are private, should not be private. So they are differentially private. Like basically the releases have some noise added to it. So you can't backtrack to the data. So we have multiple different statistical methods. Some of them I segregated it in different ways. So some of them are some standard deviation, quantiles, percentiles, and histograms, covariance, skew, correlation. All of that is present within OP Pandas. And all of the releases are differentially private. So if you want to calculate the various variance or the count of the private series, you can just do dot where and send in the epsilon because this is a differentially private release. You need to send in the epsilon. So you can just get the epsilon, send in the epsilon and get the result back. So you can just print variance and count. You can also find the bounded max and min using the percentile method. Basically, percentile is equal to 0 is the first element, that's the min of the sample, and percentile 100 is the max of the sample. That's how you can imagine this. So the actual min and max for this private series, as I mentioned above, was 0 to 100. So if you use differential private releases, obviously there will be some noise added to it. So the minimum for this is 0.599 and the maximum is 98.3. This is done using the percentile method in which you send epsilon and the p. P is the percentile. The percentile you want to get. I'm so sorry. So moving ahead, we also have advanced statistics like correlation and all of that, correlation, covariance, skewness, and all of that. So to get the correlation, it's exactly the same as pandas. You just put dot correlation and epsilon is equal to 3. So it will just calculate the correlation between different columns. So here I'll just export the private result, and this is the private result, and which I calculate for the private data frame. and this is the actual result, which is the correlation of the age and the salary of the actual data frame. So as you can see, these two are pretty close because I've used a very big epsilon. This is just for showing you. Channel 3 is pretty huge, so it's not recommended to use such a big epsilon. Next, we also have histograms. So you can just create a differentially private histogram using private data frame.hist. And let's say I want to do create a histogram of salary, how the salary looks like in the private data frame. So I'll just take create the histogram, the his data, and I'll just export it. Now, once it's exported, you can do whatever you want with it. Now here I've plotted it in nice histogram using plotly.graphs, graph objects. So this is the output of what the salary column looks like. What's the amount of people with zero salary, 20K salary, and so on. The bands, bins for that. So this output is also differentially private. That's why you're able to print it. But anything which is non-differentially private, you won't be able to print it or see it basically. Now, as we are all done, we can just terminate the session, and that is done using session.terminate session, and it will throw output status is okay. So now we're done. So hope you enjoyed the OP Pandas API guide. If you have any questions or anything, any bugs you find, please let me know. We can fix them right here.
Awesome. Thank you so much, Hardik. I'm going to quickly show by sharing my screen one minor point around sign up. I think people are having a little bit of an issue with it. So if you stop sharing, I'll just show.
Sure.
So basically, guys, like I think maybe if it was not clear. So for example, when you open the collab notebook, this is how this cell number 2 is going to look like. It is just going to show client name, client secret. It won't have an actual value. Okay, so what you need to do is you need to go to the basically the antigranular.com. You need to sign in. First, you need to sign in with your Gmail ID, and then you click on this little model that you are seeing in the corner. And here, even you can't really see any details. It's also showing all asterisks. But once you click copy, it will say copied. And then you go back and you just select this cell and you paste it. And you will see that this will suddenly populate with all of these details. And that's how you know that this has happened correctly. So that once you have those details, and then when you press and you ask the cell to execute, you will get this like, okay, it's setting up the Enclave server. It will start basically doing the handshake that connects you to the Enclave server in the backend. And then it will load the data set. It will do all of the things in the backend. And you will be, once everything is set, you will get this message from it. And that's how you know that your session is now correctly set up. I'm just saying it in response to some of the question in the chat that it's not populating these details. So make sure that it is doing these detailed population when you paste it into the cell. If it is not doing that, then maybe the copying hasn't happened correctly. So quick question from, yeah, please go ahead.
Thanks, Adi. Now it's working.
Awesome, fantastic. Really happy about that. So another question in the chat, can I get some context on the difference between a data frame that undergoes private import and private data frame itself?
Okay, so what private import is basically just taking the data from your local environment and putting it in the enclave. So it's not converting the data frame into a private data frame. You can still use all the functionalities of normal pandas if you do private import of a data frame. But when you do private data frame of DF, it will convert it into a private data frame. So it'll be you won't be able to access the granularity of the data. You'll only be able to access some of the functionalities of the pandas and all of that. So that's the difference between private import. Private import is just importing the data. Private data frame is creating the private data frame. I hope
Yeah,
that.
And Hardik, just to clarify, for example, in private import, like if I private import a CSV file from my local environment to the secure enclave, can I still do normal pandas functionality on it, even if I'm using the percentage AG cell magic?
You can't because if you upload a CSV, within the enclave, it's a secure environment, so you can't use read CSV and all of those functionalities present within Pandas because those are blocked. All the output operations are blocked within uh, the AG environment.
Okay. And Hardik, if you can put your email ID in the chat as well. By the
Sure.
way, guys, we are also available on Discord. If you guys want to uh, ping us any questions there, we have more of the team there. So maybe Hardik might not be able to respond directly to every email right now, but on the Oblivious Discord, you can also go to our channel there, and we have more of the team there constantly responding to the question for UN Datathon participants. And I'm going to post the Discord link here shortly. Any other questions from the team while we do that? Does that mean private import is not included as part of the pet track yet, unless we use private data frame? No, you can actually do private import. You can private import your own data sets. And because you have to remember that the overall UN Datathon, the purpose is that you can combine any publicly available data set and you can layer them onto each other. So for example, the data set that you will be getting for the pets track, it is a specific data set. But if you think that combining that data set with some other information or other publicly available data sets would be useful, then you can for sure just use that and use private import to add that data set into the enclave, and then you can do a lot of other operations on that data set. Any other questions? Yeah. Provide us the Discord channel. Yes, I am. So here is the Discord, my friend. So you can just go there. You can join the chat group. So we have the AG private open TP hack. We also have the anti-granular, and you can ask for help in any of those, and we will respond directly. I'll just show everybody like quickly the yeah. So if you go to the link I have shared on Discord, you can go to the ask for help channels in there, and you can create or if you find a bug as well, you can report a bug and we will respond to that quickly as well. Usually the team is very quick. You'll get an answer in an hour or two. Any other questions from people on the chat? Okay. So guys, quick reminder, I mean, we will be again here on Monday, and on Monday we are going to do another coding classification model coding along. And actually, we are going to make it a super beginner friendly session. So if you have not coded a classification model before, please join the session. We will go from basics. We are not really assuming any prior knowledge. I mean, as long as you know basic Python, you will be pretty good. The only thing I would probably encourage is just set up your Colab ID, and you will be good to go. No GPUs needed on this one. You will be able to access all the resources from the secure enclave or from Google Colab. And yeah, I think like that's it for this session. Thank you everybody for joining. Thank you so much again, Hardik, for taking us through that. Yeah, and see you guys on Monday. Take care, everyone.